All right. Hi, and welcome to our very first podcast. I'm your host, Mark Hoffman, and I am North Carolina State University's current viticulturist and small fruit extension specialist. I'm also an assistant professor at North Carolina State University. And my co-hosts today are Amanda Lewis, undergraduate student at NC State University, and Alexa Ardis. She studies international studies at NC State and is a web developer and digital creator. So welcome. And this is also the end of the 2022 virtual Muscadine school that started back in January with pruning webinars. And this is also the very first podcast that we're going to do. And the first of many, I hope. And we have some guests as participants, and we please ask any questions over the discussion we have today into the chat box. We will address those chats later at the end. And Alexa and Amanda will pick the questions. And then our aim is today to lift the things, what I will call biological commons. So the things that are made by or from living organisms and that we take granted in our lives. And one of those common things, I would say arguably probably the best of all those things, is wine. So we'll talk about wine today and how is wine made. And we have invited some experts for this because I'm not a winemaking expert, nor is on any of our co-hosts. I'm still very much a rookie when it comes down to winemaking. And so we have three experts today, which we discussed this with. And the first one I would like to introduce is Renee Threlfall, Dr. Renee Threlfall from the University of Arkansas. She is a research scientist there, has a BS in microbiology and an MS and PhD in food science. And she's also, I don't know for how long, Renee, but you're the secretary of the American Society of Enology and Viticulture Eastern Section. And
over 10 years, for sure.
Over 10 years, and it would not work without Renee. I can tell you that right now. She's doing all the heavy lifting, where we're just sitting on our butts all the time. And she's also on the Extension and Outreach Committee of the National Grape Research Alliance. And and you have a very odd split. For anyone who doesn't know what the split is, that's usually if you are working at the university, you get signed up to do research, teaching and extension. And your split is very odd. It's like 48% research and 18% teaching or what? So how does that
numbers I can't even remember. I mean, why can't they just do 15, like even numbers?
I know.
So I have a three-way split between teaching, extension, and research. It's a tough to do that, but I do enjoy all the pieces, really. So, but when you have a three-way split, it's hard not to overcommit to each of the splits. I would have trouble with this. I don't even know how I would translate this into real life, So Renee, then our second guest is Dr. Sara Spayd. And Sara has a very, very long career in viticulture and winemaking, and also degrees in food science from the University of Arkansas. So Renee and Sara know each other for a very, very long time, to my standards, for a very long time. And Sara is retired. I'm actually in Sara's old office here. I remodeled it a little bit, Sara, if you want to look at it. And but I am in Sara's old office, and Sara is the former viticulture and extension specialist at NC State. And I did put my feet into very large footsteps. She's also the award winner of a Lifetime Achievement Award of the American Society of Enology and Viticulture for her lifetime work in the realm of grape and enology. And Sara, what exactly did you do over here? What's the main achievement that you would say over your time
as a researcher?
I think I got to watch two fledgling industries grow, one in Washington and one in North Carolina. And I had less time to watch it grow in North Carolina, but I think working with the growers in both and winemakers in both locations was probably the highlight. It's a lot more fun to talk to them than it is to the university administrators.
All right. So, yeah, I mean, I can just tell you from my own experience, it's not always fun to work with the university administration. Most of the time it isn't. All right. And then our last guest who just logged in and is ready and set up, I guess, is Justin Taylor. Hi, Justin. And
how's it going, Mark?
You're coming through loud and clear.
Excellent.
So Justin is a winemaker at Parker Binns Vineyard here in North Carolina. And what I didn't know about Justin is that he was, before he became a winemaker, he was a real estate person. I don't even know exactly what you did in real estate. You probably made a lot of money and you're very rich now. That's probably what happened.
It was a career that never started. That's how I ended up. I actually am blown away. I had 10 years ago the chance to work with Sara when I was a student at the community college. So yeah, this is a really cool opportunity.
Cool. Yeah, so Justin is a winemaker for how many years now?
10 years.
10
so
years.
the first vintage I did was with the community college in 2013, and then I started there as a student in 2012.
All right, cool. And yeah, and Sara and I, we had the opportunity to drink one of your products last time. You remember when I texted you? Yeah.
I've lost track of a few of them, but
yeah, that was Sara and I. We tasted your wine. It was pretty good. I liked it. It was very good. Yeah. So this is our panel, and we are trying to, so you can consider like me, Alexa, and Amanda as the rookies, and we're going to ask a bunch of, probably for you, very stupid questions, but we will hopefully enlighten everybody a little bit about winemaking. So, and as I said at the beginning, we're talking about what living organisms can contribute to our daily life. And I think like wine is like a very, very good example, because there are at least in my opinion, there are at least 3 living organisms that contribute to a bottle of wine. And you know, Renee, do you know which 3 organisms we're talking about?
Well, I assume you're talking about the plant itself.
Yes.
And the yeast that we use when we're making the wine. I feel like this is a test. And then the third one I'm trying to think of, but I would assume, well, I mean, you have yeast, but you also have bacteria that sometimes are used in winemaking. So I don't know if you're counting that as the third thing or not. So I have 2. I think I got 2 out of the 3. So
I'll say, okay, yeah, we're pretty good. You passed the test.
oh gosh.
Yeah, but I didn't even think about bacteria. No, the third organism is humans. We are
okay. I forgot about the person that drinks it. You're right.
Yeah,
you're right.
Yeah, we're making the wine. So I think for the first, just for like all the listeners later who don't know a lot about winemaking, I think we should talk a little bit about fermentation and when grapes are usually fermented and what that actually means. And so, and to my understanding, fermentation usually happens after the grape harvest and the grapes are crushed. And then after that, for me, that's a black box. I don't know what's happening after the wine press. So if you could enlighten us, that would be very helpful. So I give it to anyone, like Sara, do you want to start?
Okay, well, whether you press or not depends on the color of the grape and what your product does, what product you desire. If it's a white wine you can press immediately, or you can, if you want to extract some flavor, give it a short skin soak. Reds will be fermented on the skin, and then the grapes will be pressed. And when you do that is the winemaker is tasting the wine as well as monitoring the change in sugar content in the fermenting juice, or must, as we call it. So that's another new term. The combination of grapes and the juice after you crush is called must. And the same way as you say, I must do this, it's must. So if you don't do something, but then you add yeast, or if you're a wild and crazy guy, you may try a wild fermentation and see what you get, but I'm not a big fan of that.
So a wild fermentation, Justin, did you ever do a wild fermentation? Like not by accident?
Intentionally, yeah.
The only intentional wild ferment that I ever participated in was at the community college, where we just locked a tank off with CO2 and allowed it to essentially decompose. I mean, you're not exactly taking your raw materials and giving them a track to run on. You're allowing them to kind of choose which direction they want to go. And I think the worst part about that, and maybe why Sara even admits to it not being a favorite, is that there's a whole host of things that can consume sugar and acid that create a lot of not pleasant characteristics. And yeah, I mean, the enjoyable part of what we're doing is what's in the glass. And if it doesn't speak to where the fruit was grown and what we find, pleasurable in the final wine, it's not always the best product.
Vinegar and goat come to mind as some of the aroma characteristics.
Yeah, you have to think about there's hundreds of different pathways that a juice can turn into something.
Yeah.
And so when you have a controlled, inoculated fermentation with a yeast, you are basically giving it traffic signals to show what way we want you to go to make the sugar turn into ethanol and carbon dioxide. But if you don't have the proper yeast or the proper microorganisms and you're doing a natural fermentation, it just goes on maybe the expressway in Europe. That's how I imagine it. Just like crazy people driving all over the place.
Hey.
You don't know if you're going to get vinegar. You don't know if you're going to get fingernail polish remover aromas. You don't know if you're going to get ethanol. So, really, I think of controlled fermentation as kind of, think about a highway with lots of traffic lights, and you're following the rules.
And you're trying to set the rules.
Yeah, you're setting the rules and you're controlling. Yeah.
So
and you use some SO2 along the way, usually sulfur dioxide, to help direct the guys you're adding, the correct yeast. And the Wild West is more sensitive to sulfur dioxide, and it knocks them out. So that's why we use sulfur dioxide. One reason. There's another reason, but it's one of the reasons that we use sulfur dioxide.
So that was one of my questions. First of all, I oppose that you compare that to how we drive in Europe, strongly. I think we drive
dog eat dog world in the tank.
It's a very efficient way of driving.
Yeah. So we do have a question in the chat, and that's relevant to what Sara just said. She said, Chuck is asking if we deal with the rogue yeast before pitching the selected yeast. And that is, yes, we do, using typically a very low level. And the key here is low, like at 30 milligrams or per liter or parts per million, less than that. And the yeast that are wild are very sensitive to SO2. So when Sarah's saying pitching SO2 in, that's really to control those wild yeasts who can have fermentations that go rogue. And we but it won't inhibit your fermentation if you're using a microorganism that is made for wine fermentation. Another thing I should add here, I teach a class here, and I always tell the students that if you are a home winemaker, that you want to be sure to use winemaking yeast and not bread yeast, because these yeasts are different. They're made for different things. Bread yeasts are made to produce carbon dioxide for bread to rise, but you want to use a selected microorganism.
So I think to dial this back a little bit, when you say they're made for, so I think it is not very apparent to everyone who drinks wine that people buy specific yeasts to actually make the wine and then try to not use, because there are yeasts everywhere around the environment, you know, so they try not to use the yeast that naturally occur on the grape skin or in the environment where the cellar is. And that's why they use SO2 or you know, it's like sulfur oxide to control the natural population. So you say that those yeasts that people buy, if I understand correctly, are more used to, you can say, like treatments of sulfur dioxide versus the ones that are naturally occurring.
No, they're just tolerant species.
Tolerant.
Like maybe, you know how different people have different
Right.
susceptibility to colds and stuff like that. Same thing. So you have yeast that are just more tolerant, and the species of Saccharomyces, which is the main yeast we use, is a species that is very tolerant of SO2 and ethanol.
Yeah.
Which is why you typically, they're actually, you know, when the companies are making these wine yeasts for people to buy, they're actually, you know, getting them from valid fermentations, and they know which ones are the healthy ones and which ones do well.
Okay. You see, that was, yeah.
Can I throw something towards the educators related to some of those species of wild microbes?
Mm-hmm.
Yeah.
So in the cellar, I have been using Michnikovia pulcherrima and Torulaspora delbrecki. Where are your feelings on those as microbes that help compete against the bad guys?
So now we're getting into the weeds.
This is
I
getting
have literally
very
no
fun.
idea what you just said.
So I'll pitch in first here. So I have a student that's working on a yeast called thermotolerance, and so it is a wild yeast, and so it's co-inoculated, so it actually is used to adjust the pH. So you know, basically it lowers the pH like you would not believe. We've already shown that. And so, you know, the yeast that you're saying, you know, they what we don't know is how long do they survive. You know, you may be putting them in, and initially they're probably are doing adding different flavors. I don't know about competing, but they definitely probably adding their own unique characteristics. But unless you sample later on to figure out if they're still there, I'm not sure how long they survive.
Okay.
Because they probably are not very tolerant to as the ethanol levels get higher. I don't know. Sarah can comment about that maybe.
Well, that's I was glad Renee said that, because I'm less up on other yeast species, but I know that the different strains that are used for winemaking they're also have a tolerance of sugar content, or can have, or be selective if you're dealing with high sugar must for late, which we don't do here, late harvest very often, if at all, in North Carolina, but in some situations you would. But the one thing I would add is that when you're selecting yeast, one thing to look at is what their SO2 production level is, because yeast will produce sulfur dioxide during fermentation in and of themselves. And I ran into this with someone who had produced in a different state, had produced a wine without the addition of SO2 and inoculated with, you know, with a standard Saccharomyces yeast strain that happened to be a high SO2 producer, and he sold it internationally as a low to no SO2 wine. Well, that when they ran the SO2s in that country, they were at least as high as a standard SO2 addition in the winery, if not higher. And I just asked one question of the winemaker, And that was, did you use blah, blah yeast strain? And he said, yes. And I said, that's a high SO2 producer.
Interesting. So I feel like we could talk about yeast the entire hour. It feels to me, I had no idea it's such a big topic. It feels to me.
Oh, it's a color palette for winemakers.
Yes. But generally my takeaway is that we basically use the yeast capacity to kill itself at some point also to produce certain wines because they're sensitive to ethanol and SO2, and they produce both as they grow. Is that kind of correct, at least? So you would use, if you want to produce a high percentage ethanol wine, you would use a different yeast than for a low percentage ethanol.
Correct.
Wine. Yes. Okay.
And temperature also plays an effect
Right.
on that.
So, but we also want to talk a little bit about the different wine types, especially also Muscadine wines. And I know some of you have some experience with Muscadine wines and winemaking. I give it to Renee again, if she can point out like the big differences between, let's say a white Chardonnay and a Carlos.
Okay,
Wine.
so yep. So Carlos is a bronze Muscadine. And one of the questions in the chat was, what is our ideal, I believe, soluble solids or sugar level of a grape? And so I think let's start with that, because, when we have Chardonnays or, white wines were typically of the vinifera category that we're used to, they'll typically be harvested between 20 to 25% sugar. But muscadines tend to be lower than that. And that's fine. That's just what their harvest is, somewhere between 15 and 20%. So the sugar levels will be a little low. Now that's important. Why? Why? Because sugar turns into ethanol. So sometimes you would have maybe lower ethanol levels in a muscadine wine than you might have in a Chardonnay.
Right.
But in terms of the methods for making the wine, the processes are actually very similar. You're harvesting the grape, you're crushing and destemming, and then for the white, you're going to be pressing it, and then letting it cold settle overnight, and then making adjustments. And here's where the difference may occur, what adjustments you might want to make in terms of the white, and then adding your yeast and maybe some nutrients, which I think the process actually is very similar to a regular wine.
Interesting. So Justin, did you ever make Muscadine wine?
I've not made Muscadine wine, but this might be close enough to be dangerous. I have made Norton for some time.
Oh, okay.
I'm very, very fond of it. It has its own challenges that I would say can maybe kind of touch on what issues you would see with chemistries related to other cultivars, in particular with Muscadine.
Okay. Yeah. So for everybody who doesn't know, Norton is a American cultivar as well. So it's
Vitis estevelius.
Yes, exactly.
Yeah, it has pH problems, I believe, is what probably Justin is talking about. Very high pHs,
High
pHs, but high acids.
Yeah.
Yeah. As a conundrum.
Yeah. Yeah. And
I'd like to mention one other difference between what I think is the difference, and it gets between viticulture and enology, and that is the variability of the muscadine maturity when it comes into the winery. Typically, you see a lot of variation, particularly depending on how the machine harvester is set on knocking fruit off. But it's hard to avoid getting immature fruit in.
I agree. Yeah.
And I don't know how many wineries are using sorting belts, like a lot of the premium, like a lot of the vinifera wineries or European grapes are using to sort. One of the grad students that was at Arkansas when I was there did a sorting study on using. This is something you wouldn't do commercially. He used
Density.
Solution on density, but if I went back and looked at his data, I'm sure we could see that you would be able to sort by size to some degree to cut off the really immature fruit once they've been through the destemmer to break them up. The other thing I think we can do is to take, and this throws it back on Mark, one of the old recommendations from the North Carolina State Department of Agriculture when you'd send in your petiole analysis was to apply 200 pounds of nitrogen per acre to the vineyard per year, which is a huge amount of nitrogen.
Yeah.
And we've not looked at what the effect, and the goal then was yield. When that work was done, was to increase or maximize yield. Muscadine wineries I talked to before I retired, we're starting to think more about how can we improve the quality of the wine through the grape. And one of them is going to be, I think, looking at nitrogen management and getting the percentage of immature fruit that comes in down that goes into the wine.
Yeah. Well, that's a whole different episode for a podcast. Really.
No, but I thought I would mention the sorting.
Yeah, no, but it's really right. So wine quality, or like the quality of the wines, really starts with vineyard management. That's true for vinifera grapes too.
Yeah.
Yeah.
But I mean,
Yeah.
That's one example.
Right.
And I think the other, we're going back to the difference. You picked a white, but with a red, a black muscadine on the winemaking, it is you do have to let it stay on the skins a little bit to extract some color. But I'd say the risk with muscadine that is different than the Vitis vinifera, like Cabernet Sauvignon and those, is that you need to limit this because muscadine skins can be really bitter.
Yes.
So the longer on the skin, in this case, you do get the color that you need. That's why you're fermenting on the skins for muscadines, is you're going to get a little color. So you'll go, if we pressed a black muscadine without skin contact time, it would be a light pink color, if not clear. But if we press it, if we let it ferment on the skins for a little bit, it's going to start pulling out some of the colors. But the longer you do that, you're going to have more extraction of other compounds that maybe will be a little harsh.
Right.
And also the color stability of muscadines in general is not as good as Vitis vinifera or your typical wines. So really muscadine wines are more of a short-term wine, like you consider like a Beaujolais or something like that. So, you want to consume those in the first year. They just have the color pigments in a muscadine are more in the orangey red category than the purple, dark blue category of a Vitis vinifera.
So we have 5 minutes left, and I have 2 questions for like everybody, and then we have a question in the chat box that I would like to answer. But I know a little secret about what you just said. So I don't know if it's a secret, but I know that some muscadine winemakers particularly use vinifera grape juice, like Petit Verdot, for example, for the especially for the color in small percentages to like get the color darker than. Yeah, so that's a lot of people do that. So, all right. So we have 2 more questions. The first one is, it's going to be rapid fire. So if somebody starts out with muscadine winemaking, first time they make muscadine wine, what are the mistakes, or first time they make wine, what are the big mistakes they should avoid? Everyone has like one mistake to say. Justin, temperature.
My one big mistake that I would say in winemaking is that you need to use an antioxidant. Sulfur dioxide is your friend, or else your wine will turn to vinegar.
I'll pair that with oxygen management from beginning to end of the process. If you do everything right and manage your wine wrong with too little oxygen at the beginning and too much oxygen toward the end of the fermentation process, you're just going to have a sherry, a brown wine.
I'd throw one other in, sanitation.
Oh,
sanitation is always.
I'd say I agree with Sarah that of all those things, that when I'm looking for a winemaker, I'm looking for an OCD person who loves to clean. Yeah, and follow rules.
Yeah, it's not gonna be me then.
No.
Yeah, well, I took a shower this morning, so
Well, it was your weekly shower time.
it's like that's like once a week. That's my shower time. So let me follow up with this quick, like, oxidation. So what can happen if you don't look at your oxidation, Renee? Just very quick.
Okay, so early in the fermentation, the yeast needs oxygen to do what it does to ferment. But later in the when the fermentation starts slowing down, you want to have no oxygen really available for in contact with the wine. So if you're moving it from carboy to carboy, you want no headspace, none.
Oh, okay. I see.
So you want to limit the headspace as you move forward. And on top of that, before bottling, you want to sparge that wine because some oxygen is bound. It's like stuck in there and you can't see it. But if you asparage it with nitrogen or carbon dioxide, it'll push it all out like you've poured a soda and all the CO2 pulls up to the top, and then you bottle it. Because oxygen management, SO2 addition, that all has to do with, quality. Basically, if you don't have good oxygen management, the wine becomes oxidized, kind of like apple juice. So it'll get that kind of brown, sherry-like color and aroma, caramels.
Yeah, I saw that.
And the color will brown.
Okay. All right. And then this is the one question that Alexa, do you want to ask your own question probably? So it was a really good question. So I want to ask that question to everybody.
Yeah, sure. So I was just wondering, what do you guys wish you had known before you started making wine? What's a tip for beginners that you might not find on the internet?
Take a lot of chemistry and microbiology.
Yeah, there's a bit of science involved, but let's go back to sanitation. I think cleanliness is the key. Like, I wouldn't realize, like, if you spend 1 minute doing something, you should spend 10 minutes cleaning before and after. So yeah, cleanliness is what's going to lead to a good wine.
Renee,
and no Clorox.
Your office must be the cleanest office in the whole
It is
planet.
so not clean, but I do hire clean people. And let me add here. So we talk about sanitation. In the winery, we don't use bleach.
Yeah, no Clorox.
So we don't use chlorine-based products. We have a reason for that, which is a whole nother episode of a podcast.
Yeah.
But we're going to use iodine. We're going to use caustic agents. SO2 can be used for cleaning, ozone. So there are other things you can do to clean and sanitize, but they're non-chlorine based. And I say that in the winery, but let's go back to the viticulture as well. So you should use it all the way through the process.
Yeah, you don't want to clean your harvest bins with like Clorox or something.
No.
Yeah.
Especially if they're wood.
Right. Especially if they're wood. Justin, you have the last word.
Well, the thing that I would have to say is, because I've definitely gone on a journey that has taken me from science into stylistic guidelines. So if there was something that I could have gone back and told myself 10 years ago, it would have been to understand how the science drives what you're doing stylistically in the final wine.
Yeah.
And that doesn't mean you need an organic chemistry degree. It means you need to understand, when we talk about wines, we might say the word balance, but balance actually breaks down into pH numbers, acid in grams per liter, parts per million of certain items in a wine. And those are not romantic, but they're pretty real when it comes to working with volumes and making something that we all get to enjoy. So.
Which I really like, because you bring the science back into romance, which is really nice. I really enjoy that a lot. So Chuck has like I feel like Alexa and Amanda, did we miss a question in the chat box? I feel like
Chuck's asking how long to ferment on the skins, and so typically this would be, I would say not more than 3 days, but with a muscadine, I'd say even 1 day,
even
1 to
less
3
than that.
days.
Yeah.
Well, the other thing you need to worry about with skin contact on muscadines is they have a compound in them called ellagic acid. I know
Exactly.
that's and you can't get rid of it. I mean, you can fine it, do all your fining, or that's another whole topic, but you will get it reforming in the bottle no matter what you do.
Yeah. I would keep the skin contact pretty low. I mean, I feel like 3 days is pretty long already for muscadines.
And it causes a haziness
Yeah. So if you're looking for color, you might want to add another grape in a small percentage. That's what some people do. If you
Actually, what we do sometimes also is maybe run it through a heat exchanger and then ferment.
So Chuck,
Yeah.
if you have a heat exchanger, you can do that.
Yeah, I mean, low temp, like it's like 100. It's not very much at all, and it just pop it through.
All right. Cool. So did we answer all the questions in the chat box over this discussion? Cool. Justin, thank you for your time. And
this has been a tremendous opportunity. I mean,
we're going to do more of those.
Free space, but also to be able to see Sarah 10 years down the road for all that you've done.
Still looking good.
Yeah, your hair is quite a bit longer than it used to be.
Well, that's thank COVID. I've been cooped up still for 3 years.
You should have been making wine. I mean, that's like the age-old pastime.
She's been consuming wine. That's the other pastime.
I've been trying.
That's Mark's third living entity, as we'll end the podcast, right? Is
Right.
the consumer.
The consumer.
Eventually, what we want to do is make wine that people will drink, and that's the
Yes.
goal. And if you follow the things that we've talked about today,
That'll help.
what we'll have.
Yes, I agree. Well, thank you for everybody's time. I really enjoyed this. This was way too short. We need to do this again, a little bit longer on a more specialized topic. But thanks for all your time. This will be recorded, and you will also see this on the Small Fruits website, and because it's part of the 2022 Muscadine School. And I really appreciate everybody's time. I'm happy that we bring science back into romance. I really like that. That should be like the topic of every podcast now, Justin. And I talk to you guys soon, and happy holidays if we don't see each other again. And thank you for your time. I appreciate it a lot. Thank you.
Thanks.
Au revoir.